Hey everyone, and thanks for tuning in for my talk today about vulnerability inheritance, finding bugs, and scoring bounties with third-party integrations. It's a great honor to present my session on the DEF CON AppSec Village, and I hope you all will enjoy it and learn some stuff for the future bug bounty hunting experience. Who am I? My name is Nagli. I'm 23 years old. I'm an AppSec researcher at NZ Security. I'm a BSc computer science student. I'm a bug bounty hunter by the alias of Nagli on HackerOne, Background, and CNAME, and I have my personal blog where I post write-ups on at galnagli.com. So, preface for the session today. How will this session benefit you? We'll talk about third-party integrations. I'll give you examples of third-party integrations, why should we hunt for bugs on third-party integrations, and how to identify assets running third-party integrations. Later, we'll go over reconnaissance. Improve your subdomain reconnaissance flow, locate all bounty targets running a certain vulnerable component, and create Nuclei templates for mass fingerprinting tasks. After the reconnaissance part, we will look over a short overview of the attack vectors and chaining for impact, and some proof of concept for my own bug bounty experience. Approaching bug bounties in 2021. The number of bug bounty programs is a never-ending list. There are so many programs with so many assets to test and explore. Which assets should we focus on after the reconnaissance phase is a question often been asked by bug bounty hunters. A possible solution for that question would be targeting the assets maintained by third-party integrations. Let's go over third-party integration examples. First, there are HTML-based third-party integrations, such as Intercom Live Chat, Analytics of Marketo, and Billing of Stripe. Secondly, and this is the part we will focus more on in the session today, are DNS-based integrations, such as customer service of Zendesk, e-commerce of Shopify, marketing of Oracle, forums, service, blogs, webinar, teaching, and basically there are a lot more third-party vendors who offer integrations of certain functionality to our websites. What are the benefits of targeting third-party integrations? First, there are a variety of services. There are many vendors around different areas. So there are many vendors to find bugs on. There are many types of them. They are all on different niches, so we can find some specific business logics error on different vendors, which will affect the target we are targeting with our bug bounty hunting. Second, we'll be deploying forget strategy, often a blind spot for our target after the initial configuration. So after our target implements his help desk portal, for example, he will go over the initial configuration, but he won't monitor it for any emerging CVEs or vulnerabilities which are not assigned CVEs, but are considered a web 0 days or 1 day, which are being published on ExploitDB or on Twitter. It can affect the target. The third point will be one bug, many vulnerable assets. If we find a bug on a third-party vendor, every asset on the internet who uses this vendor is affected. The final point will be defense mechanisms are not enforced on DNS integrations. If we have strict WAF or CSP on our main and critical assets, it will probably not apply on the subdomain that we are hosting, which actually aliased a third-party vendor. So if we host a subdomain with a CNAME third-party integration, it will most likely not have the strict WAF or CSP that we've set to protect our main website. In this session, we will be focusing on the DNS-based third-party integrations. First, let's go over how does DNS-based integration work. So we have CNAME and A records. Before diving into the integration flow, let's take a look at the following example about CNAME and A records. So this is an example from Wikipedia. And for example, we have DNS zone as the following. We have bar as a subdomain, for example, .com, with a CNAME record to foo, and we have the full subdomain with an A record to a certain IP address. What we actually do when we search a URL on the browser tab, we actually issue an A record lookup for the bar subdomain. The resolver looks for A record for an IP to display the contents of our website. But because it actually points to a CNAME record, it will check again if foo have an A record behind it. He will go over all the CNAMEs until he finds an IP address. When we are looking at foo, we will find the IP address specified, and we can log the content for bar, for the initial search. Let's have another example of support subdomain at example.com to be help desk running Zendesk. So the flow is as the following. We have the customer to visit the support subdomain. The resolver will look for the support subdomain A records or its DNS records. It will find that it had a CNAME record to a Zendesk subdomain named example. Now we know that the example subdomain at Zendesk actually have an A record to display. So what the resolver will do now, it will look for the DNS records of the example subdomain at Zendesk. It will find that it has an A record, so it will display the contents of the example subdomain at our support subdomain at the main website we look for. So the main takeaway will be that the support subdomain at example.com is aliasing the example subdomain at zendesk.com. The contents presented on the target subdomain are exactly as on the third-party integrated website. So now let's go over the reconnaissance part. The flow will be divided to two key areas. The first will be to discover third-party vendors integrated with our target. We will do subdomains lookup for it, passive, active permutation. We will resolve the subdomains, and we will extract CNAME from the resolved domains. The second phase will be to discover assets maintained by a third-party vendor. We will use Google Docs, reverse CNAME lookup, customers page, and pass fingerprinting with Nuclei. So first, let's discover vendors integrated with our target. We will take wildcard.example.com as our example target. So we'll start with subdomain reconnaissance. First, we'll do passive subdomain lookup. These are the tools that I use when I do passive subdomain lookup. Subfinder, Chaos, Amas, Robot, GitHub subdomains, and Web URLs. They all have in common that those are passive subdomains lookup tools. We don't issue any active request to our target. They all collect the data from different resources on the internet. The expected output from this process will be generic subdomains, such as help, admin, dev, and shop. Many bug bounty hunters stop at this phase. They think they found all the available subdomains on the internet for our target, and they continue their hunting from this point. This is a huge mistake because they miss a lot of domains by relying only on passive subdomains lookup. The second phase will be active subdomains lookup, which is brute forcing. I use pure DNS for the brute force and asset not word list for the word list. The expected output will be unique subdomains, such as admin dev, S3, assets, internal dev, and test stage. The third and another important phase will be permuted subdomains lookup, which is DNS gen for the permuted generation of the subdomains. The expected output will be unique permuted subdomains, such as int, admin-dev, qa-test, dev-assets, or panel-s3. We take the entire subdomain that we found up to this point and add some critical and non-internal subdomain names to those endpoints to see if there are some variations to specifically to our target. Leaving one of these steps aside will leave you with less subdomains than your competitors, and you will surely find less subdomains of your target. So it's critical to follow each of these steps when you're doing bug bounty hunting, and especially on the reconnaissance phase. The next step will be to resolve the collected subdomains. We will use pure DNS for it. We will ask it to resolve the list of subdomains which we found up to this point. We will use the resolver's text file. We will save the results on the resolved subdomains.txt file. Later, we will extract the CNAME records from the resolved subdomains using HTTPX tool. We will issue the CNAME flag. We will grep for closing bracket to display only the subdomains which have a CNAME record on it. As we can look on HackerOne subdomains, we can see that there are a few third-party integrations that they are using, like Zendesk, CloudFront for hosting the GSLink subdomain, Uberflip for the resources, and GitHub for some of their documentation. Now we'll go for exploitation. After we extract the CNAME records from the resolved domains, we should opt for either of the following. The first will be exploitation of the CNAME provided instance to find unique vulnerabilities. There will be more to follow in examples. And the second will be probe the subdomains for non-CNAME related wonders, such as on ExploitDB or on Twitter. If you see someone that reported a unique bug affecting certain vendor, you need to check if any of the vendors you found actually have some bugs published on the internet. The second phase will be to discover assets maintained by a vendor. Let's take our demo third-party integration, vuln.com, as an example. So what we'll do now, we'll scrape the internet. Utilizing certain Google Docs, such as in URL or in text, we'll look for reverse CNAMEs, for the customers page, and for the past fingerprinting. So first, let's detect patterns with Google Dorking. The first pattern to detect will be common subdomain name. For example, if our vendor is providing a learning area as vuln.com, most of the assets, which will be the customers of us, will create a new learn subdomain to host the contents of it. So we can use the site keyword of the Google Docs to look for every website which has the learn keyword as a subdomain. We will issue this request on Google search, and we will find all subdomains, all assets of the internet, which have a learn subdomain. Second, you can use the credits on the HTML page. Often vendors love to present powered by section or powered by line by the end of the HTML page. We can use this to find more instances of the same vendor with the in-text keyword of Google. The third would be with the page title. Similar like before, many vendors love to put on the title their name. So we can use the in-title keyword of Google to search for every asset that Google knows that having the in its title with their platform. The second step to do will be to find the reverse CNAMEs lookup. When we look for targets, we can know what are the CNAME records of our targets. But we can't do it the other way around. We can't ask our CNAME who points to it. The only way to do it will be to look on some online crawlers which scan the entire internet and score their data of their websites on the databases. Doing so, they have a list of websites and their CNAME records. So what we can actually do, we can navigate to one of these sites and we will ask it, do you know any CNAME record with the record of vuln.com in it? And then it will display from the database all the assets that they found before that have a CNAME record to our vulnerable vendor. So I gave you a few examples like Spicy, Rapid7, Shodan, Fofa, and attendees, which provides such services. The third will be customers page. Often vendors love to present their big customers on the trusted by pages. When you go to the marketing websites under www, you can find it if you scroll down below the customers drafted by. Often, some of these will have bug bounty programs, and it makes the job easier for us finding vulnerable assets. The final point will be past fingerprinting. We will be weaponizing Nuclei. Let's take a look on a real-world scenario that I found 6 months ago of Open Redirect on all Thingific instances, which is a teaching platform. The signatures that indicates the vulnerability will be a CNAME record pointing to anything under thingific.com, and that the path of the URL as API, SSO, D2, SSO, JWT go to every.com will actually redirect us to every.com. So now we found that every asset which operates under Thingific is affected, so we want to find all assets affected by the vulnerability. We don't want to go over each subdomain and try on the browser search bar the following path to see for the redirection, so we'll use Nuclei for our help. Let's look over how to create a Nuclei template. We'll go over each field at a step. This is the YAML file for the single to redirect I've shown before, and now we'll get a little bit deeper into it. First, we have the ID, which is the alert name when match is found. When we find a vulnerable website, the tool will return us in the result the ID contents. In our example, single to redirect. The second part of the YAML file will be the info part. We have the also field, the also key as the also name, the severity key as the severity we set for our vulnerability. It will be printed out when we find a match. And we have a simple referencing tags, as I set here as redirect, because if you want to scan for all open redirects on all our assets, for every template that actually provides open redirect opportunities, so we can issue a scan to scan only for templates with redirect tag. This is what it's used for. Next, we have the request part. We need to specify the method we want our request to use. In our example, it will be get. Now, we need to specify the vulnerable path, which will indicate that the vulnerability actually exists. In our case, it's the same example as I've shown before. Now, we want to specify our matches. We want the tool to alert us if there is a vulnerability. So we need to tell it what to look for on the HTML response to indicate that there is an actual vulnerable instance in front of us. So I want to use two matches here. So I use the matches condition key with the end value. I want the first match to be a status code. I want the status code to be CO2, which indicates redirection. The next matcher should be a word. I want a certain word in the HTTP response to indicate me that the request actually redirected us to the website I specified. That it wasn't a simple CO2 redirection to another subdomain, but it was a redirection to every.com. So we specify on the words the value that returns to us when the redirection actually occurred. So when there is a single to redirect, it issues the following message on the AH return with every.com and certain query params like shown in the picture. So if the response of the request we send to the path we've set above includes the following word, we found a vulnerable asset. And we specify that we want the response to be on the body part of the HTML. Now, we want to execute the template on our HTTP prompt subdomains. So use cat for the known HTTP subdomains. We specify Nuclei with the template of sync to direct. And as we can see in the results, it alerts to us that we found a sync direct, which is the ID. And this is one subdomain of my bug bounty target that is actually affected by the vulnerability. So if I will copy the link that I got as a result from the Nuclei and paste it on the page, will redirect me to every.com. That's it for the reconnaissance part. We will see some of this example practical in the proof of concept section. Now, let's go over the attack vectors. So we found a self-party integration. What vuln types should we look for? I suggest focusing our attention to client-side vulnerabilities, such as XSS and open redirects, for the following reasons. 1. They are easier to discover. 2. The server belongs to the vendor. We need to remember that if we attack a third-party integration as a CNAME or with an IP, the IP address is actually the vendor's. So if we find RCE or SSRF, it's a legitimate vulnerability, but it affects the vendor. We want to find the vulnerabilities to chain to affect our bounty target and not the vendor. So it's better to focus on client-side vulnerabilities. The third point will be chaining bugs. So we want to find the small bug that will help us to have greater impact on the target we are hunting. So let's look at the attack vectors and chaining for impact. First, we have DNS misconfigurations, such as subdomain takeover and dangling DNS records. Subdomain takeover occurs when we have a subdomain that points to an instance like Shopify, S3 bucket, and the Azure instances, which the record is no longer claimed by the organization, but on the registrar, the subdomain still points to that record. What we will do, we will capture the subdomain, and then the content presented on the target subdomain will be in our control. Dangling DNS records is actually really similar. We can take, for example, EIP of AWS. If our target used on his registrar to point on an EIP subdomain, on an Elastic IP, and he released the Elastic IP from his AWS account, but didn't change his records, we can brute force for Elastic IP until we get a match with our target, and the impact is actually the same as subdomain takeover. The second part will be client-side vulnerabilities, such as cross-site scripting and open redirect. Now the chain for these vulnerabilities on our main asset, main target, main background target will be one, business logic errors. For example, we can take over Shopify subdomain and put our credit card on it. So customers will make purchases on the subdomain of the target thinking it's a legitimate website, legitimate shopping website of our target, but the money will go to us. We have course bypasses. If our target on his main asset of functionalities relies on the request being issued from one of its subdomains, if we have cross-site scripting or any DNS configuration, we can send requests from the subdomain of the target. So we can bypass the course protections, which look for requests originating for one subdomain of our target. Cookies exfiltration. We can exfiltrate cookies scope to the main domain of our target that can lead to account takeovers. SSRF bypassing. If we have certain functionality which issue requests from certain resources of our target, and it only allows to put subdomains of our target, if we have open redirect or cross-site scripting dangling DNS records, we can actually control the redirection to another internal resources of our target. By doing so, we can bypass SSRF protections. And the OAuth bypassing, if we have redirect URL to any allowed subdomain of our target, and we control the redirect from a certain subdomain, we can issue a redirect which will possibly leak the host code of our victim for our controlled instance. So these are the attack vectors and the checks we can do, and I hope it will be more clear with the proof of concept section. So now let's look at some POCs. The first one will be SSRF, FCC, stored XSS, and open redirect on a certain webinars vendor, which will be redacted for this talk, although the vulnerabilities are already fixed. Our target was events.hackerone.com, and the 3 reports are already disclosed for my account for about 4 months. And you can look at the links that are provided here after the talk as well. So what I actually did, I wanted to find some bugs on HackerOne themselves. So I did a subdomain reconnaissance, and I found events.hackerone.com as one of the subdomains. It looked actually a little weird for me because it doesn't look like the actual development that HackerOne uses on their main website or other subdomains. So I had the suspicion that it's actually a CNAME. So when I ran the CNAME probe on it, I've actually seen the response with the CNAME for a redacted webinars vendor. Later, I wanted to perform endpoints reconnaissance on the CNAME record. To do that, I used Wayback URLs tool by Tom Nom, which fetches the saved endpoints for our target from Wayback archive. I looked for any URL param, query param, to find open redirect, SSRF. It's something that I usually do after I search for endpoints on a certain target. And in the response to our request, I've seen the following facts. Conferences get recording slides XML.xml with a query param of URL. It sounds really promising. So the question is, will the endpoint fetch external assets or XML files and render those? If it does, I can achieve XSS on HackerOne subdomain. I thought there is no chance for it to happen because we're talking about HackerOne here, and finding the subdomain wasn't really hard, although it actually worked. The vendor with the conferences get recording site XML URL fetch the contents I presented on attacker.com XSS XML, or you can see the IP of my server with XSS payload on an XML file, and I managed to achieve a cross-site scripting on HackerOne subdomain. I reported this to HackerOne and several other programs on HackerOne and background, and I got a few bounties from it. The next one will be stored openly direct on a teaching platform. The targets were Twitter, Snapchat, Amazon, Facebook, and the vendor was Intel. So what I've done was looking for bugs on Twitter. So I did subdomain reconnaissance on Twitter. Later, I found that flightschool.twitter.com, the take flight subdomain, and twitterflightschool.com itself are pointing with a CNAME record to intellum.com. We can look on the page rendered under twitterflightschool.com, and we can actually see the powered by signature that we discussed earlier with Intellum value in it. So what I did, I was scrolling the application for any vulnerable endpoints, and I found the following widgets, experience, destination URL, which accepted any external asset that I've put at the destination URL key value and redirected to it. What actually happened is if the victim visited the URL I've shown before, whenever it tries to navigate to any endpoint on twitterflightschool.com or the other Twitter subdomains, it will issue a request to get student and redirects him with CO2 status code to every.com. So it's actually stored openly direct. He can't navigate to any other functionality on the Intellum website he's navigating on, and every time he hits refresh or navigates to another endpoint, he will be redirected to our control domain, in this case to every.com. The only way to break out from it was to clear the cookies or close the browser session. So after I found out the vulnerability and I've seen that it's actually running on Intellum, I wanted to do reverse CNAME lookup. I used Spicy for this particular case, and I looked for any CNAME which includes Intellum on its record. I found out two results, one for Amazon and one for Facebook, which operate bug bounty programs themselves as well. So it was nice to see the vulnerability that I found from hunting on Twitter affecting Facebook and Amazon from the same hunting session. So I reported this to Twitter, and the report is already disclosed. I reported it to several other programs and made some nice bounties from it as well. The next one will be stored success through email marketing integration. There were many private programs affected, and the vendor is Oracle Responses. The View in Browser feature allows customers to view their emails on the browser with a dedicated subdomain of our target. So as you can see from the pictures in the right, there are some emails after we sign up that allow us to view in browser, or can see this email, click here. HTML injection rendering on emails is quite common, but considered as a low impact issue, as you can see from the image on the right. Therefore, targeting bounty targets to utilize responsive email templates, which provides the view in browser functionality, will help us escalate the HTML injection issue to stored cross-site scripting on the targets. So what I did, I found that responsive uses certain pattern for the URLs displaying the client emails, which includes the following string: pub ss forward link. I use the following Google Doc with the in URL Google key, and it helped me locate some interesting targets who might be prone to stored XSS vulnerability. What I did, I supplied first and last name inputs on sign-up forms of any bounty target who uses responses with an XSS payload like shown below of image SRC, and I waited to receive emails like the following structure presented on the email. I wanted to see only the closing tag. That means that there might be a rendering of my email. And after we see some indication, like the picture shows, I clicked on View in Browser. Clicking on the View in Browser button will direct us to the affected subdomain for the target. So as you can see from the pictures, I found several stored XSSs after clicking on the View in Browser because the page rendered our first or last name with the cross-site scripting payload. So I reported it to several private programs and got some bounties from it, so it was really nice. The next one, it's not public yet, but it's important to SAP already, is an open direct on all SAP NetWeaver 7.8 versions. The targets are many programs, and the vendor is SAP. So the discovery. As I was testing a new program, I manually went through some of its subdomains and found an interesting endpoint which indicated this actually running on SAP. So I was authenticated to some functionality on the subdomain, and I wanted to log off. The following endpoint was accepted through post request. Simply changing it to a GET and setting my website as the redirect URL value resulted in an open redirect within more than 10,000 websites using SAP NetWeaver. So when I try to log off from the subdomain, it issued a post request, so I changed it to GET and put my own blog as the redirect URL, and I had an open redirect vulnerability. So what I did, I created a Nuclei template to scan at scale. I want to alert for a vulnerability if the response in exchange to our request on any subdomain that I have in my records by providing the following path will return a status code of CO2, which is the direction, and the location header of my blog, galnagli.com. So I ran it on my targets, and I found several of these, which alerted back the sub redirect with the link of the vulnerable instance. So I actually found 142 targets affected and reported several of these. I discovered this last month, so there are probably more targets affected that I didn't scan. Let's go over the summary of the talk. So the key takeaways I want you to take from this session is about one, attacking third-party integrations is profitable and it's fun. Finding a single bug that affects many assets gives you more profit and more value for the work you dedicate instead of finding single specific bugs on targets. The second point will be reconnaissance. It's a critical part of successful bug hunting. You can't rely only on passive resources. You want to find as much subdomains as possible. Scaling up equals saving time. You can't navigate to million subdomains with a certain string to search if it's vulnerable. You have to use Nuclei or other tools that allow you to send hundreds of requests a second to many subdomains instead of doing the manual work. The third will be impact. Always opt for chaining bugs. There's nothing wrong reporting low or medium bugs to many programs as long as it's in scope and you get value from it. And the last point is anyone can do it. None from the vulnerabilities that are presented in this session was really complex to find. We just need to know where to look at. So I thank you very much for tuning in. You can hit me up with feedback or follow-up questions on my Twitter at Nagli. And I thank you all and wish you a very happy and successful event going forward. Thank you very much.